So here's a circuit. Just like we've been doing, we're going to determine the current, the voltage, and the power on each resistor, right? And so let's draw some currents through here. We'll call this guy I1, right? Because I can call it I, it's the total current going out, but it's also going through I1. Notice this guy is in series with these two which are in parallel, right? And so this I1, which comes through here, has to split into I2 and I3. Right? And so I have to determine all of these if I want to determine any of the currents. And so the first thing I have to say is, well, if I want to treat this as all one resistance, which would allow me to determine I1, I can say, well, look, 1 over R parallel is 1 over R2 plus 1 over R3. This is the first thing I have to do. I can't include this resistor because this resistor isn't either in series or parallel with either one of these two. So I first have to identify, oh, these two have both ends connected to each other, so they're in parallel. And so this is 1 over 30 ohms plus 1 over 60 ohms. All right. And so if you do a little math on that, you'll see 1 over 30 plus 1 over 60 is 2 over 60 plus 1 over 60, which is 3 over 60. When you invert that, you get 20 ohms. 60 ohms, so divided by 3, or 20 ohms. And so I can treat these two resistors as a single resistor, R parallel. That's not a very good marker. Try another one. R parallel, which is 20 ohms. Right, and now I have two resistors in series, R1 and R parallel, right? And so I can say R series is equal to R1 plus R parallel. I meant to do that in black, which is 40 ohms plus 20 ohms, which is 60 ohms. Now I can say, look, this total, all of these resistors combined here have a resistance R series, which is 60 ohms. And then I can say, well, I is equal to V over R series, or I1. I call that I or I1, right, is equal to the voltage, which is 12 volts, divided by 60 ohms, which is 0.2 amps. And so that tells me that the current through R1. And now I can use that. I can say, look, I can say V1 is equal to I1 R1, which is 0.2 amps times my 40 ohms, which is 8 volts. And so that tells me that the voltage drop across this guy is 8 volts. And what that tells me is that since this is 12, what's left for these guys here is 4 volts. And so that means that V2 equals V3 equals 4 volts. And so now I have all my voltages. I have 8 volts and 4 volts for 8 volts for V1 and 4 volts for V2 and V3. And now calculating I2 is just V2 over R2, which is 4 volts over 30 ohms, which is 0.133 amps. Similarly, I3 is equal to V3 over R3. Again, V3 and V2 are the same because they're in parallel, and so this is still 4 volts. this is over 60 ohms. And so this is 0.067 amps. I didn't write that very well. And so now I have the currents. Now I have all the currents as well. I have I1, which is 0.2, I2, which is 0.13, and I3, which is 0.067. That gives me the current through each one. Notice, by the way, that this one plus that one equals that one, right? This current is split up into those two, and so when you're all done, you better get the answer that when you add this current to that current, you get the total current in the circuit, right? And so I1 equals I2 plus I3. That gives us a little check. Okay, and now I can calculate. So now that I have all the I have all the currents, I have all the voltages, I can calculate the powers, and so I can say P1 is equal to V1 I1, which is equal to 8 volts times 0.2 amps, which is equal to 1.6 watts. P2 is equal to V2 times I2, which is 4 volts times 0.133 amps, which is 0.533 watts. Let me just check that. Yep. And then P2 is equal to V3 I3, which is equal to 4 volts times 0.067 amps, which is 0.267 watts. And so those are our powers, those are our currents, and that's the whole picture.